Hello, physics world. My name is Alexis O'Connell, and today, for our physics discussion, we're going to be talking about the work-energy theorem. And in this example, we're going to be talking about an airplane trying to land on an aircraft carrier. And there must be someone special on this plane because they're trying to make it land. And because of that, we are assuming that there is someone very important on that plane. So we don't want it to crash. So the question is asking for us to find how much work is done on the arresting cables on the plane and what is the force exerted on the plane by the cables. So in order for it to land on the aircraft carrier, there are these cables that come in and make it attach to the base. And when this is occurring, the engines are still in full throttle, just in case the cables don't attach properly. The pilots have to be ready for the plane to take off at any moment. So this is a big deal, this is happening, and we're going to try to figure out the physics of it. So we're given the initial velocity in the x direction is 67 meters per second, and the final velocity is 0 because we want it to stop. And it says that it travels on the ground for a distance of 84 meters before it stops. So in order to find the work on the plane, we have to use the kinetic energy in order to find that. And because we're not going to use potential energy because we don't have any forces or anything in the y direction, because we just have the mass, which we're given 220 kilonewtons, which is also 25 tons, which is a very heavy airplane. And I guess we have the normal force on that, but we don't really have any other forces in the y direction. So it's just traveling in the x direction, so we just use the change in kinetic energy of the plane. So we know that the change in kinetic energy is 1/2 mv final squared minus 1/2 mv initial squared. And we know that the final velocity is 0, so that cancels out. So we're left that work is equal to the kinetic energy of the initial situation. So the total work of the system on the plane. So we plug all our values that we know into the calculator. We're given in the weight in newtons, which is a force. So we need to find the mass, which is just in kilograms. So in order to do that, we divide by the acceleration due to gravity, and we get this value right here. So we just plug these values into the calculator and get this. And we know that it's in joules. So then for the next part of the problem, so we found the work, and so to find the force that the airplane exerts, the force that the cable exerts in the airplane, we know that work equals the change in kinetic energy plus the change in potential energy. But there's another formula that says work is equal to the force times the distance times cosine of theta. And we can rearrange this problem to get force on one side. And so we divide by r times cosine theta, and we get work divided by r cosine theta. And cosine in this situation is just 0. So cosine times 0, cosine of 0 is 1. So we don't have to take that into account. But if we did, we could just plug that in, the angle right there, and I'll give you the answer too. So because this is 1, we could just leave that out, and we could just plug in the work that we were given, and then divide that by the distance that he traveled that we're given, and that gives you the force. And that's it. That concludes our discussion about this very important person that did not crash on the plane. So thank you. We know that this is a safe flight.